Alright guys, welcome to this video where we will explore the sine rule. So every single trigonometric question that we've experienced so far has been in terms of a right angle. Now, what happens if the triangle is not right angle? What do we actually do? So if we recall our knowledge from geometry, we actually know that when we look at the opposite side to an angle, we denote those as the same letters. So if we've got a little b, that means it's the side, and if we have a capital B, that means it's the angle or the vertex. Now, because we can only work with right angle triangles, if we construct a right angle triangle by creating a perpendicular, creating a right angle within that triangle, and now we've kind of cut it in two parts, we've got two right angle triangles. Now in the triangle BCD, which is the triangle on the left, if we look at sine B, that is equal to opposite over hypotenuse. So looking at B, we're looking at opposite over hypotenuse, which is h over a. Now if we multiply both sides by the value of a, well, we end up getting h is equal to a multiplied by sine b. And we're going to use that property in a moment. Now in the other triangle, triangle ACD, the one on the right hand side, we've got sine A is equal to opposite over hypotenuse, h over b, opposite over hypotenuse, which is equal to, or h is equal to b multiplied by sine A, where we multiply both sides by b, and we end up getting h is equal to b sine A. Now the thing here is we've got the height of that triangle is equal to two different values. Now how could that be? How could two different values be equal to something? So what we do is we equate those. We say, alright, h is equal to this expression here, h is equal to that expression here. If we've got h is equal to two different things, they must be the same value. So we express it like that. We say h is equal to a sine b, h is equal to b sine a, so they must be the same. Now, what we can do from here is divide both sides by sine a sine b, and we do that to both sides of our equation. Now if we do that, the sine b there and that sine b will be cancelled, so will that sine a and that sine a. So essentially what we've got left on the left hand side is a over sine a, and on the right hand side we've got b over sine b. That's all we have left. So that is our expression for the sine rule. That's what we end up getting. Now it doesn't look too simplified. You might be thinking, now what do we do with this? But this helps us out immensely when we don't have a right angle triangle. So this is a very important property when we look at non-right angle triangles. Now we've only worked it out for the two particular ratios. Now if we kind of oriented the triangle in such a way, we would end up getting c over sine c as well. So the three ratios are equivalent and they exist. Now that's pretty cool because now we can work out unknown side lengths. But what we do notice is from here we've got four pieces of information. We've got one side, one angle, another side, another angle. So essentially we've got four parts to the equation. So if we wanted to work out a side length, that's the equation we'll use. The little a on the top and the little b on the top, and the capitals on the bottom, the angles on the bottom. That's if we were trying to find out our side. Now, our work with equations can be manipulated in such a way that this is our new equation. If we wanted to work out an angle, we work out the angle from this particular equation. We kind of like flip it upside down. It's basically just cross multiplying and dividing by AB, and we end up getting this particular equation, which will help us work out the missing the missing angle. This one's for the side, and the second one's for the missing angle. So when is the sine rule used? Well, we've got a non-right angled triangle. So if you had a right angled triangle, we'll obviously use our SOHCAHTOA or our sine, cos and tan ratios. And if we don't have a right angled triangle, if it's all acute angles or an obtuse angle triangle, we could use possibly the sine rule only if we have two sides and two angles. Obviously, one part is missing. One part is unknown. So 1 is unknown. That's if we had two sides and two angles in a diagram. Alright, let's actually apply this special rule that we've just come up with, the sine rule, in this particular question. We do have two sides and two angles here, so we're going to use the sine rule. Two angles are given, one side is given, the other one is unknown. So when we said one is unknown, that means we don't know what that one is and we're trying to find it out. So step one is to write down the correct sine rule. Is it the side or is it the angle? So in this case, we've got a missing side, so we have the little letter or the little a on the top. And what we need to notice here is the a's are opposite each other. So if we're going to choose this one, it must be in relation to that 55. And if we're looking at 50 degrees, that's opposite the 23. So that will be 23, and that one will be 50 degrees. So the opposite parts are on the same side of the equation. So step one is to write the formula. Step two is to substitute, like we just had a look at. And over here we've got a fractional equation. So to get rid of the sine 55, we multiply both sides by sine 55 degrees. And then we can say that, okay, these two guys are eliminated, and then all we've got left is x is equal to this particular part here, and that's done on the calculator. So just type that out into the calculator and we end up getting the value for x. And finding x to one decimal place, if the question said to one decimal place, we round it off. So make sure your calculator is in degrees mode, and then you should end up getting 24.6. Alright, question 2 is looking for a missing or an unknown angle, not a missing side. So we're not going to use the same equation as we just had a look at. We're going to use the one where the sine A is on the numerator. Here's our formula. So these guys are opposite each other, so theta and 12.3 will be on the same side, theta and 12.3. And we've got these two opposite each other, so that's 67 degrees, and this one is 15.2. So substitute the values in, and then here we've got a product of 12.3 on both sides. To get rid of those two, and here we've got sine theta is equal to this particular fraction. And to work out what theta is, we find the inverse sine of that particular fraction. And you can type that out into the calculator. And in exact form, make sure you know how to use your calculator to put it in degrees, minutes, and seconds. So the two different calculators, you've got degrees, minutes, and seconds. But before you press that button, you have to press second function, and that's on the Sharp. And on the Casio, you just press the degrees, minutes, seconds button, which looks like speech bubbles. And that gives you the answer in exact form. Otherwise, you'll get it in decimal form, but we like to have it in degrees, minutes, and seconds. If the question says rounded off to the nearest minute, well then you do that. Alright, thanks for watching this video on the sine rule. If you have any particular questions, just make sure you put your comment below. Alright, thanks for watching.